So yesterday we talked about arithmetic series. Today we're going to talk about geometric series. So the definition is fairly simple. A geometric series is just the sum of a geometric sequence. Remember, the sequence is the list of terms. The series is the sum of them. All right, so to find the sum of a geometric series, we have a formula, just like we did for arithmetic. It is the sum of however many terms we're talking about, okay, equals, and we have a big old fraction. In the numerator, it's a1 times 1 minus r to the nth power over 1 minus r. So for the arithmetic series, we had to know the first term, n, and the last term. Notice we don't have to know the last term here. But with the arithmetic series, we didn't have to know the common difference. We needed it if we needed to find a term, but we didn't have to know it for this actual formula. But here, I do have to know r. What does r represent? The common what? What does r stand for? You have a common difference for arithmetic. For geometric, you have a common ratio. So n is the number of terms. A1 is the first term, which is not always the first term in this sequence, but it's the first term you're using in your sum. Remember that. And r is the common ratio. So we're going to find the indicated sum for each geometric series. So on number 1, we need n. What is n for number 1? 9. Yeah, right there. The first term is what? 2. Okay? I don't care about the 9th term, but I need r. What is r? 5. So once I have that, then I can find the sum of those first 9 terms. It's the first term, which is 2 times 1 minus 5 to the 9th power over 1 minus 5. Go ahead and type that in. See what you think. All right, so you should have gotten, what, 976,562? I should have had y'all take a wild guess at what the sum would be. But remember, these are geometric. That's an exponential increase as far as the values are concerned. All right, let's look at number 2. I need the same things. I need n. What is n in number 2? 8. First term is 72. And r is what? Negative 1/2. So you go ahead and find this. Well, actually, before you do that, ask yourself whether you think the answer is going to be positive or negative in the end. You don't have to tell me. Just take a wild guess at that, and then go ahead and find the sum. $765 over 16. Yes. And we can tell that it's going to be positive from the beginning, because if I have 76 and then negative 36. So that's, I'm subtracting half. Then I'm adding more back, but I'm only subtracting half. Like, you're never subtracting more than you're adding, so it should stay positive. Okie dokie. Let's look at number 3. What's that Greek letter called? Sigma. So this is your sigma notation. I still need to know specific things here. And I need n. What would n be here? 7. Okay. I need the first term. So when I substitute 1 in here, 1 minus 1 is 0. What's anything to the 0 power? 1, so the first term is just 3. What is r? Your geometric sequence formula is a sub n equals a sub 1 times r to the n minus 1 power. So we know this is geometric series. It told us that, so they're all in this form. Didn't even really have to do the whole exponent thing to get my first term. This is my first term. So what is r for this one? Negative 4. Okay. So then we can substitute that in. The sum of the 7 terms is the first term times 1 minus a negative 4 to the 7th power over 1 minus a negative 4. And be careful with your signs and your parentheses and all that stuff in your calculator. You definitely don't want to get something wrong because of something like that. Any questions at all? Okay. We don't need to do number 4. And we're actually only going to do part of number 5. Okay? So I know by looking at this, the first term is 7, right? But is that the first term that I really want? No. What's the first term I really want? The second term, right? So I really want A2 because that's the first term in my series. Yes, A1 is 7, but that doesn't really help me. So I need to figure that out. That's going to be 7 times 3 to the 2 minus 1 power. So that's really just 7 times 3, which is 21. What is n here? 12. How do we find n? It'll be 13 minus 2, then what? Plus 1. Okay, so that's where you get 12. And then what's r? 3. Okay, everybody okay with where all that came from? Okay, we're not going to finish that problem. I want you to do number 6 all on your own. Everybody get that number? You good? You're getting that number if you're still punching buttons? Give me a second. All right, we good? All right, let's look at a couple of application problems. So the grocery store started raising money for local schools. In their first month, they raised $4,000. Each month after, they raised 1.5% more than the previous month. Find the total money raised in 4 years. Okay, so let's find in. We're rating this monthly, and we got 4 years, so what's in? It's not 4, because we're going by months. How many months are in 4 years? 48. Okay. What would my first term be? 4,000. Okay. Yes? All right, so then I need the rate. Well, it says they raised 1.5% more, so 1.5% as a decimal is 0.015. Is that my rate? No. What's my rate? If I put that in as a, in here, a sub 1 times 0.15, oh, 0.015, I can't even write the right thing, 0.015 to the n minus 1 power. When you have an exponential graph, if this is less than 1, isn't that a decreasing graph and not an increasing graph? So when it's 1.5% more, you have to also include what the original was. So your rate is 1.015. So it's actually 101.5% of last month's. Okay. So now that I have that, and go find the sum of those 48 months, that's going to be equal to 4,000. That's my first term. Times 1 minus 1.015 to the 48th power over 1 minus 1.015. So before you start typing that in, I want you to just think about, they made $4,000 that first month. If it's going to increase by a little bit more than 1% in 4 years, just make a prediction. You can just tell yourself, you don't have to tell anybody else, about how much do you think it is, and then find how much it is. I suck at that game, by the way. I would never get it even close, but just, Do what? Yeah. It's not $1 million, but it's still a pretty good chunk of change, right? Then, since it is an application problem, we need to write out a sentence. Total amount raised in 4 years is $278,260.88. Does 3 decimal places make sense here? No, because it's money. And your dollar sign is your unit, so it's important. And the dollar sign goes before the amount, not after the amount. Okay. Any questions at all? Yes, sir. $4,000 times 1. Oh, because I wrote it wrong. Did I write it wrong? I wrote it wrong. That's why. Y'all did what I wrote up there, and I didn't write it right. And nobody stopped me. It should look like this. Sorry, it's not the whole it's not the whole parentheses. It's this that goes to the 48th power, not the whole thing. See where I added those parentheses? That's why. Sorry about that. Y'all are usually pretty good about calling me out. All right. We good now? All right. So let's go look at Carol. Carol wants to be a millionaire, don't we all? She saves 1 cent the first day, 2 cents on the second day, 4 cents on the third day, and so on. How many days will it take her to save $1 million? Okay. So let's find N. Do I know N, or is it what I'm looking for? It's what I'm looking for. Okay. What's my first term? It's 1 cent, right? And if we're going to go to $1 million, then that means this is 0.01. Okay? And R is equal to, what would the rate be? 2. It's 2, because 2 divided by 1 is just 2. Okay? So we're going to set this up like we have the others. We usually put I would put SN, but I know what that is. That's $1 million. I'm trying to get to $1 million. So $1 million equals, then I have my little fraction here. I have my first term, which is 0.01 times 1 minus 2 to the nth power over 1 minus 2. I put the exponent on the correct thing this time. Everybody with me? Okay. So now, if I do 1 minus 2, that's a -1, right? So I'm going to go ahead and multiply both sides by a -1 and get rid of that. So I'm going to get a -$1 million equals 0.01 times 1 minus 2 to the nth power. Okay, everybody with me? So now I want to get rid of this. So I'm going to divide both sides by 0.01. That gives me, so divide 1 million by 0.01. Tell me what you get. It's 100 million, right? -100 million equals 1 minus 2 to the nth power. So just solving for n, so I'm going to subtract 1 from both sides. That'll give me -100 million and 1 equals -2 to the nth power. So now I'd like to get rid of that negative, so I'm going to multiply both sides by -1, so I get 100 million and 1 equals 2 to the nth power. I need to get n out of the exponent. What process does that? What? What allowed us to take exponents out of the exponent? That's bad. No. What? Log. We take the log of both sides. So I've got the log of 100 million and 1. You can do the natural log or the common log, it doesn't matter, equals the log of 2 to the nth power. So you have a rule with logs that the exponent can come out in front here, so now we have the log of 100 million and 1 equals n times the log of 2. So now, what do I do to get n by itself? Don't push buttons yet. Divide by the log of 2. So I get the log of 100 million and 1, no pushing buttons yet, divided by the log of 2 equals n. Okay, so the question's asking how, if she saves 1 cent, then 2 cents, then 4 cents, and so forth, how long would it take her to save $1 million? Of course, assuming she had that amount to actually put in the bank or whatever. So I want you to make a prediction to yourself. You don't have to tell anybody. Make a prediction about how long it will be. I'll give you 5 seconds for that. Everybody have a guess? Even if it's a guess, you got a prediction, right? Okay. So now type this in and see what you get for n. Calculator gave you 26.575. Okay, so when we're talking about days, your answer is actually 27 days. Anybody come anywhere close to 27 days? Or were you all way over, like on The Price is Right, you have no hope, right? Okay. Seems a little nuts, right? I have a book that I'm going to read you during the last week of school that kind of goes over this, but it is a little, sometimes, we talk about reasonableness of an answer a lot. Does this answer seem reasonable? No, it absolutely doesn't, but it is the right answer. It's reasonable if you think about it, because remember, these are exponentials, right? We started with 1 cent, but it goes like this. Somebody last period figured out how long it took you to even get to $1, and then he sat there and did it on his fingers, and he's like, yeah, it does take you 27 days, whatever. Go for it. But it's an exponential increase, and so you are going to get more and more as it keeps doubling. Okay? Any questions? We good? Yeah, 27 days, but you have to have the pennies to put in the bank to get to that, so, All right.